Hello, this is the next lesson of trigonometry. So today we will study three-dimensional Pythagoras theorem. But before going to that topic, before that, we will study Pythagoras theorem in two-dimensional. All right, I will explain you Pythagoras theorem in two-dimensional, and after that we will move on to Pythagoras theorem in three-dimensional. We will be also studying how to apply Pythagoras theorem on different shapes, for example pyramid and a cuboid. Okay, so we will be studying all these things in today's lesson. So let's start and understand Pythagoras theorem. This is very important. If you understand Pythagoras theorem in two-dimensional, then you will be able to apply this concept on three-dimensional shapes as well. So first of all, remember this point that Pythagoras theorem need to be applied on a right angle triangle. In the first lesson of this chapter, I explain you a right angle. What is a right angle triangle? So you can see a right angle triangle here. This is a right angle triangle. This side is A. This side name is A. This side is B. And that side is C. This is a right angle triangle because there is 190-degree angle. This is a 90-degree angle, right? And I explain you that right 90-degree angle mean that when two lines are perpendicular to each other like this way, when two lines are perpendicular to each other, it means there is a 90-degree angle. This is a 90-degree angle here. So this is a 90-degree angle. So it means this is a right angle triangle, and we can apply Pythagoras theorem here. So last time I explained you that uh, that opposite to the 90-degree angle is hypotenuse, and let's say this is the angle given x, so opposite to that will be opposite, that is opposite, and the last one is adjacent. So these are the three names of these three sides of a triangle. All right, but I also explained you that hypotenuse will be the longest side of a triangle. You can see hypotenuse, this is the longest side. So now in this question, two sides are given. This side is given, that is 3. The value of this line, this side is 3, and this is A. The value of this line or this side of the triangle is 4. And the name of this side is B. So B is equal to 4, A is equal to 3. And we need to find out C. We need to find out hypotenuse. So this is the scenario here. We want to find out the longest side of this triangle. Or you can say, in other words, we want to find out the value of C. That is C there, right? And since B is given here, this side is given, adjacent is given, and opposite is given. These two sides are given, and we need to find out the hypotenuse or C. So here in this type of question, when the triangle is a right angle triangle and there are two sides given, you can find out the third side by using Pythagoras theorem, right? You see this side is given, which is 4, that side is 3. We need to find out C, the hypotenuse. So here you can apply Pythagoras theorem. So you can see I have written here, apply Pythagoras theorem to find the value of C. We need to find out the C. Now let's discuss about the formula of Pythagoras theorem. What is the formula? The formula is this one. This is the standard formula, but I will explain you an easy way as well. Okay. This is the standard formula of Pythagoras theorem. That is hypotenuse square is equal to opposite square plus adjacent square. By the way, you can write this as well: hypotenuse square equal adjacent square plus opposite square. So it does not matter, you can flip these two because addition is commutative, right? You can write like 1 plus 2, 1 plus 2 is 3, and 2 plus 1 is also 3, so both are the same thing. So in the same way, you can write opposite square plus adjacent square. You can write adjacent first and opposite the second, it does not matter. So this is the standard formula of Pythagoras theorem. In most books, the formula is written in this way: c square is equal to a square plus b square. Actually, c is the hypotenuse. C must be the longest side in the triangle. Okay. If you want to use this formula instead of that, so then you need to keep this in mind, that C must be the longest side of the triangle which you are solving. So that is the longest side, and then you can write the other sides there on that way, like a square plus b square. You can name a any of other side, b another side, right? So c square is equal to a square plus b square. So you can see I have written the formula over here. This is the formula which you will be using in order to find the value of c. Now let me make this a bit simple for you. So actually Pythagoras theorem, in order to apply Pythagoras theorem, the simple concept is that you write the longest side here, whatever the name you want to give, the longest side, but c is better if you choose c, the longest side of the triangle. So the longest side square equal the other two with a square, right? So it means that just write longest side square equal side 1 square plus side 2 square, right? So you just need to write the longest side there with a square, equal that to side 1, which is a square, plus b square, which is the other side. So there are three sides, right? Three sides in a triangle. So longest side square is equal to the other two square with a plus in between. So this is the simple version. Even if you don't memorize that formula, still you can work on that, but you need to understand the concepts behind these. Okay. While applying Pythagoras theorem, you should know that how this formula has been derived. This is actually hypotenuse square equal opposite square plus adjacent square, but you can apply that in a direct way instead of finding every time which one is hypotenuse, which one is opposite, which one is adjacent. This will become a bit complicated. So the simple thing is the longest side square equal side number 1 square plus side number 2 square. Now, so that is the longest side. So I want to find out c. So c square. So now I will put values here. Put values. So a is given, that is 3. A is 3. So put 3 here with the square. B is 4. So b is 4 square. So now solve for c. 3 square is 9. 4 square is 16. Add them together, 25. And this is c square equal 25. Now I want to find out c, not c square. So for that, take square root both sides. So take square root here, take square root here. This square and square root will cancel out and it will be c, and square root 25 is 5. So c is equal to 5. So we got that side which is 5. So c is equal to 5. So actually you have calculated to find the one side of the triangle by using Pythagoras theorem. Now let's assume there is another triangle, and now this is given. Let's call this is 12, or let's make this 5 to make it simple. 4, I'll make this 3, 5, 3, and we want to find out this side, right? So that is the longest side. So the simple version is take the square of the longest side. So longest side is 5, so 5 square equal the other two with a square. So 3 square plus, which is unknown, so call that as a. You will call that as a square, right? So actually I have used this formula. I have used this formula, a square plus b square. What I did here, I substituted the values in the formula, but I made that simple for you. You just need to take the square of the longest side equal to the square of the other side and the square of the third side. So third side you want to find out, so keep that as a square. So now let's solve it. So 5 square is 25, 3 square is 9, equal a square. Sorry, this is plus. Now since you want to find out a square, so this is simple algebraic equation. So what I will do, I will shift this 9 to that side. I hope you learned these methods in algebra chapter. You shift this 9 to that side, so it is positive 9 plus 9 here. You shift it to the other side, it will become minus 9. So 25 minus 9 equal a square. 25 minus 9 is 16 equal a square. Now you want to find out a, right, instead of a square, so take square root both sides. So a is equal to 4, so you got a. So I applied Pythagoras theorem here, right? So this is how you apply Pythagoras theorem in a simple way, that you just need to take square of the longest side equal to the square of one side plus the square of other side. So this is Pythagoras theorem. You can see I have written a note here. The note is that apply Pythagoras theorem on right angle triangles only. On right angle triangle only. You cannot apply Pythagoras theorem on other triangles. Remember this point, this is a very important point. Now let's understand three-dimensional Pythagoras theorem. So we'll come to the formula. First we will understand the concepts, and then I will explain you how the formula actually work. Now how three-dimensional Pythagoras theorem is related to the two-dimensional Pythagoras theorem. Both are related. So first let's understand the concept. This is the three-dimensional Pythagoras theorem. Three-dimensional Pythagoras theorem actually means that we need to apply that on 3D shapes. What is a 3D shape? This is a 3D shape. That is a three-dimensional shape, right? So now let's apply. So the scenario given here, this is the question. So you focus here on this triangle, on this shape. There's a shape. Focus here now, and now let's see what we here want to find. So here we want to find out that D. We want to find out D, right? This is a three-dimensional box. You can think of it like a box. Shoes box or anything is a box. This is one corner, that is the top corner. So from the bottom down corner to the top corner, this is the line, and we want to find out that D, the length between this corner and that corner. So Pythagoras theorem was in two-dimensional. What we did there, we calculated actually C. If A and B are given, you can find out C, right, by applying Pythagoras theorem. So C, we calculated that longest side by using Pythagoras theorem. Here we need to find out the value of D. So now let's see, in order to find out D, if you see this is a triangle, right? This is a triangle in the middle of that three-dimensional shape. Triangle is, by the way, a two-dimensional shape This is a two-dimensional shape, a triangle. Two-dimensional shape. But here, this is a three-dimensional shape. The top, the whole box is a three-dimensional shape. But there is a triangle inside of that. Actually, we want to find out that. You connect that point with this one, and you connect that corner with this corner, so this become a triangle. So I will draw this triangle here. That is the triangle you see, that is D. The down part is E, this part is C. Now we can apply, now this is a two-dimensional shape, so it means we can directly apply Pythagoras theorem here. We can apply, you directly apply Pythagoras theorem in this case. So there is one problem, and the problem is, let's apply Pythagoras theorem. You will know d square, as I told you, the longest side square equal to e square plus c square, right? This is the formula. The two-dimensional, actually I'm applying two-dimensional Pythagoras theorem because this triangle is a two-dimensional which we have taken from that three-dimensional shape. But the problem is that c is given. C is given in the question. A is given in the question. B is given in the question, right? Let's assume B is equal to 3, A is equal to 4, and C is equal to 5. These are the three sides. What about E? E is not given. In order to apply Pythagoras theorem here on this triangle to find D, we need E as well. But E is not given. What to do? This is the issue. We need to find E first. So for that, we can consider this triangle. This triangle, which is on the bottom. This is the triangle. So I will take that and will draw it here. You check it, compare now. Now you see that is E. E is the bottom one. E is the top one, the longest side now. That is E. This is B. This is B. B is there, and that is A. This is A. That is A. So I have just taken this triangle and have written there. Now let's apply Pythagoras theorem here on this triangle. This is a two-dimensional shape again. So actually there is a portion, there was a small triangle inside of that three-dimensional shape. This is a triangle, we have taken it from there. So let's apply Pythagoras theorem here. So it will become E square equal B square plus A square, right? The longest side square equal to B square plus A square. Now B is given, that is 3, 4 and A is also given. So B and A both are given. So now what we will do, we will put this here in here, right? We will put this E square. We will take that E, the value of E, and we will put it here. So it will become D square equal A square plus B square. I have replaced E by A square plus B square, and I will keep C square as it is. C square. And now put your values. A is given, B is given, C is given. So put values in that. And the other way is that you find E separately first. You will get an answer, right? You put B here. B is 3 square. A is 4 square. So 3 square is 9. 4 square is 14. It will become 25. Sorry, this is 16. 25. So E square is equal to 25 and E is equal to 5. And now put E here and then put C square as well, and you will get T. So now let's discuss about, by the way, this was just the explanation. There is a simple way in order to find out that D, and the formula is this thing. This is a formula for three-dimensional Pythagoras theorem. Actually, d square, this d square, that d square is equal to a square plus b square plus c square. So it means that if you want to find out, d, so d square is equal to b square, a square, c square with a plus in between. So you just need all these three sides of this cuboid, and you can find out the diagonal. By the way, this line is called diagonal. This is a diagonal line. This is a diagonal line. You can find out the diagonal. So the formula is simple, but understand the concepts as well. This is very interesting. Very interesting, the relation between two-dimensional and three-dimensional Pythagoras theorem. Now let's solve a question. Find the exact length of the diagonal BH. That is B. This is H. This is a cube, right? This is a cube, a three-dimensional shape. But actually we want to find out that length. That is the diagonal. We want to find out the diagonal. So very simple, just use the formula a square, which is this, b square is this, c square is that. So a square plus b square plus c square is equal to d square. So what is d square? D square is bh. D is bh. So I will replace d by bh. So bh square and put all these values. 4 square is 16, 4 square is 16, 4 square is 16. Add them up all together, 48, and then there is a square. Take square root both sides, you will get the answer. The formula was simple. We just need to understand the concept between two-dimensional and three-dimensional shapes. Now, let's work on a bit complicated questions. By the way, interesting as well. These are interesting questions. You will get it. See. So, after taking this lesson, you will be able to solve most of the trigonometry question. You will be able to solve difficult three-dimensional questions like this one. In the square based pyramid shown, this is a square based. Why it is called square based? Because the base is square. The base is the down, right? That is the base. It is square. So therefore it is called square based pyramid. Shown now. M is the midpoint. M is the midpoint of the base. You can see that is the midpoint. M. Find the vertical height AM. You now see in another shape A and M, that is the middle line, which is in the middle of that square based pyramid. We want to find out AM, this line. All right. So now how we can find that? Again, we will apply three-dimensional Pythagoras theorem in order to find out that side. So let's say this is the, since this is the diagonal, but this is a three-dimensional shape, so we cannot assume this like a diagonal. Diagonal is an in a square, or sorry, in a cube or cuboid. Okay, so now what we can do, you will draw a line from the midpoint till this point and make this like that. So there are two sides, one is this one is that one is the top one. So actually I will make, by the way, understand the concept, very important, then you will be able to apply anywhere. Now this is En, that is En. Actually I will convert this portion of this square based pyramid into a cuboid. This is a cuboid. I will convert into that form. How? En is this side. This is the, by the way, there is no side. This line is not there in this shape. It will be like this. It is not there. But actually we want to make it. Let me draw. Let me show you what actually is that thing. Actually we converted this shape into this form, right? So we converted that square based pyramid into this shape, and you can see that shape over here. Now if you see, this EA is the diagonal. Actually, why we did that shape? Actually, we want to make this EA the diagonal of this another shape which we have just drawn. So it is a diagonal now. You see, it looks like a diagonal, and we have worked for a diagonal by using Pythagoras theorem. We can find out that t square, which is the diagonal, is equal to a square, that is this side. Let me draw on another color. Let's say this is a, that is b, and that is c. So this is a, let's assume this is a, that is b, and that is c. So a square is equal d square, which is the diagonal ea, is d square, that is a square plus b square plus c square. Now a square, if you see here, it is given, right? A was actually from here to here. By the way, total line is 7, so it means the half of that will be 3.5. So it means A is 3.5. We have just taken half of that complete line in order to shape this new shape over there. So A is 3.5 square. Now what is B? This is 7, the total line is 7, so it means this line is also 7, which passes through the midpoint, which is M. So the half of that would also be 3.5. So it means B is also, this is B. B is also 3.5. And C, which is AM, which we want to find out C square. Now let's replace D by AE square. Which one is D? D is the diagonal. D for diagonal, right? The diagonal in that shape, that is EA. So I replace D by AE equal 3.5 square plus 3.5 square. C, what is C? C is AM, which we want to find. And by the way, AE is also given. AE, that is 9. So put 9 here. So 9 square equal 3.5 square plus 3.5 square. By the way, it's square here. And plus AM square. Now we want to find out AM. So this is again an algebraic equation. Shift this to that side and this to that side. So it will become minus on other side. So AM square is equal to 9 square minus 3.5 square minus 3.5 square. You solve it in the calculator, you will get the answer. You can see over here as well. 9 square is 981, and you can solve these two on calculator and you will get the answer as 7.52. So these are the applications of Pythagoras theorem. Think of this Pythagoras theorem in three-dimensional in a broad sense. This is a broad topic where you can solve multiple questions on that, where you can solve complicated trigonometry three-dimensional shapes. See this square based pyramid, we assumed something new, we assumed that new shape there in order to make this EA as a diagonal, and since that is a diagonal, so now we can apply Pythagoras theorem here, right? So you can use your creativity, learn the concepts and then use your creativity in order to solve questions. By the way, that AM can be solved on another way as well, right? But in this case, at this point, you learn three-dimensional Pythagoras theorem and try to use this concept on different shapes. You will be studying three-dimensional shape as well in geometry, right? Where we will study cylinder, we will study square base pyramid, we will study cube, and so all these cone, we will study all these shape in geometry. After this we will start geometry chapter, right? So this is the concept which you can apply on three-dimensional shapes. Use your creativity, use these concepts on other shapes. So this was the question. Now let's try this one. This is a very simple one. Why? Because this is not a square, this is not a square based pyramid. This is directly, and the question says find AH. A is that one, H is this one, so this is the diagonal. So if that is the diagonal, directly use the formula d square is equal to a square plus b square plus c square. All the values are given. Let's assume this a, let's assume this b, let's assume that c. It does not matter, you can assume in another way as well. You can call 7 as a, 5 as b, and c as 12. It does not matter. So a is 12 square, b is 5 square, c is 7 square. 12 square is 144, 5 square 25, 7 square 49, d square. Add them all together and take square root, you will get the answer. So this is how you solve three-dimensional shapes. Very interesting topic. Now let's solve another very interesting application of three-dimensional trigonometry, or three-dimensional Pythagoras theorem. Mostly not Pythagoras theorem but trigonometry. So here you can find out uh, angle between line and a plane. What is a plane? Plane is actually a two-dimensional shape. This is a plane. So this is a plane. Plane is a two-dimensional shape. Okay, this is a plane. And let's pass a line from this plane. That black line is passing through the plane. Passing through the plane. Now we can actually find out the angle. We can find out the angle. Which angle? This angle. Why? How? Because this is a triangle. It will become a triangle. That is a triangle. Which triangle? A right angle triangle. So a right angle triangle is actually simple one, and solve you can solve this on multiple methods. So that is a line passing through the plane, and this is the angle which you can find. This is the method. Learn the three-step methods. Make a right angle triangle between the line and the plane. This is the plane. That is line. Step number 2. Draw a simple two-dimensional sketch. You can see this green, this red triangle. This is a two-dimensional shape. Triangle. And the last one is use trigonometry to find out the angles. What is trigonometry? Trigonometry is tangent theta, or tangent x, tan x, sin x, cos x, which I explained you in the first lesson of this chapter. So you can apply those trigonometric ratios in order to solve that angle. That is actually x. This x is angle. Now let's solve a question. A, B, C, D, E. That is A, this is B, B, C, D, E. This is a square base pyramid again, with M is the midpoint of its base. That is the midpoint. This is the same question as we did previously, but a bit different. Find the angle the edge AE makes with the base. Actually, think of it like we want to find out this angle AE. Okay, AE is a line which makes an angle With the plane, you can see that light blue, that is a plane. Assume that as a plane, the way I explained you here. The yellow is the plane to that black line. So assume this AE line is a line which is crossing or which is touching the plane. So we need to find out that angle. So this is an example for that. Let's try how it works. So again, see this example, this diagram. So there are actually two triangles. One triangle is this one. Triangle number one is this one. And triangle number two is the small here down, which is in the base, the down. And one is on top like that. These are two triangles. And we need to find out that angle x. Right? We need to find out that angle x. So I will take triangle 1 here because that is a two-dimensional triangle in 2D. So I will draw that triangle here. E, you can see E here, A on top, and M in the middle. M is that point. So it means I have assumed this is triangle 1. And by the way, in the first lesson, I explained you that you can apply trigonometric ratios, tangent, sine, cos, any of these in order to apply on this. And I explained your formula as well, that was strange or orange hamsters creep around houses, tripping over ants. So as for sine or for opposite hypotenuse, so it means sine x is equal to opposite over hypotenuse. Cos x is equal to adjacent by hypotenuse, and tan x is equal to opposite by adjacent. So these are three formulas, three trigonometric ratios. Okay. So this is a two-dimensional shape. In order to find out x, we can apply trigonometric ratio. Which one? This is a 90-degree angle, and opposite to that is hypotenuse. Hypotenuse is not given, right? So hypotenuse formula will not work. Cos cannot work. Sine cannot work. Now x is this is opposite to the angle is opposite, and that is adjacent. So now we can apply tan x, right? Tan x, that is tan x is opposite by adjacent, so opposite is 12, adjacent is not given, right? Adjacent is not given. Em is not given. What to do now to find out em is that line, this line is em, not given, right? Not given. The height is given 12, you can see over here, it is written here 12 is written here. That is given 8, that is given 8, but that is not given. Em is not given. So what to do with em? For that we will use triangle 2, a right angle triangle, that is em. By the way, half this total is 8, so half of that is 4, so it means this is 4, and this total is 8, and half of this, which is this line is also 4. And now you can apply Pythagoras theorem here. So the longest side which we want to find, so em square, 4 square plus 4 square, both are 4. Apply Pythagoras theorem directly. Okay, try to train your brain how to apply Pythagoras theorem directly without thinking of which one is hypotenuse, which one is perpendicular, opposite hypotenuse and adjacent. Don't think of it. Just see which one is the longest side square equal the other two square with a plus in between, and then solve it. So 4 square is 16, 4 square is 16, so 32. So it means em is equal to under root 32. Take square root both sides. So you can see em is equal to under root 32. So we will use this em here in place of that question mark. So 10x is equal to 12 divided by under root 32. You can see here 10x is equal to 12 divided by under root 32. And then solve this and shift this 10 to that side. So x is equal to 10 inverse. Remember, I explained you this thing in the first lesson. 12 divided by under root 3, 32. Solve it in the calculator. You will get the value of x, the angle, and that is 64.8 degree. So it means that angle is 64.8. So see, in three-dimensional shapes you can take out two-dimensional shapes from that, or you can take out two-dimensional triangles from that, and then you can apply Pythagoras theorem where required, trigonometric ratios where required, and solve for what it is asked, right? So Pythagoras theorem is important, is need to be applied on right angle triangle, and trigonometric ratio also for right angle triangle. For other triangles, in the last lesson I explained you cosine and sine rule. You can apply these two rules on other triangles. Now let's understand the sine and cosine rule in three dimension. What will happen if you get a triangle which is not a right angle triangle? For right angle triangle, I explained you the method that apply Pythagoras theorem, apply trigonometric ratios in order to solve those right angle triangles within the three-dimensional shapes like square based, pyramid, cuboid, or cube, right? So take out the two-dimensional triangles and then apply Pythagoras theorem, apply trigonometric ratios on that, and solve for the question. What about sine rule and cosine rule in three dimensional? Now this is a question given. It says find the size of the angle AFH. Last time I also explained you that AFH mean that the question is asking to find the angle with F, the middle number, the middle character F. We need to find out the angle with the middle character, that is F. So it means this is A, that is F, that is H. So it means we need to find this angle. So let's see it here. That is the yellow one, that is the triangle, and we want to find out that angle. Very interesting question. Here you will learn a lot how to apply directly Pythagoras theorem and trigonometric ratios. So you will apply, and even cosine and cosine, sine and cosine rule as well. So the yellow is a triangle which is two-dimensional. So I will take it outside here. So that is AF, AF, and H. H is this one. So I have just extracted that triangle outside and have drawn in that way, and it becomes simple because that is a two-dimensional shape, and now we will try to find out two-dimensional methods. And this is x which we want to find out. This is our aim. So remember, if you remember, in order to apply sine rule and cosine rule, let me remind you quickly. A by sine A equal B by sine B equal C by sine C. Now in sine rule, I explained you that you need to make pairs of two. You can take this two pair, you can take that two pair, you can take these two pairs, right? So you can take any of these two pairs according to the question. But let's see. Think of it. Can we apply cosine sine rule? No. Why? Because in sine rule there are two angles involved, and here we are given one one angle we want to find and there are no other angles given. So if no other angle is given, just one angle is, and we want to find that, so we cannot use sine rule, because in sine rule formula there are two angles involved, A and B, or B and C, or A and C. Two angles involved, so sine rule cannot be applied here. But if you remember, we can use cosine rule because there was one angle involved in cosine rule. But to use cosine rule, we need all these three sides. We need this side, we need that side, we need this side. We need all these three sides to find, right? So we need three sides to find out or to apply cosine rule and find out that angle. So let's try and find all these three sides. So first of all, let's find out AH. A and H. This one. Let me erase these extra things. So we want to find out A and H. So think of it. We can use this triangle, the down triangle, which is in the base. There is a small triangle, right? You can see that. The red line, which you can see, which is AH, that is the longest side. So it means that AH square is equal to, this side is given 13, 13 square plus 9 square. So 13 square plus 9 square is 250. And we want to find out AH, so take square root both sides. Take square root both sides, so AH is equal to under root 250. So we got AH, so you write 250 here, under root 250. So I will write under root 250. We got AH. Now let's find AF, that side. AF is this. Now think of that triangle. Let's assume this triangle, which is on the side, okay, on that side of the wall. On that side of the wall there is a triangle. This is the longest side of that. So AF is the longest side. So this is 6. This side is 6. And that side, is this given or not? Think of this. This is also given. That is 9. So this is also 9. So that is also 9. So let's find AF. We are applying Pythagoras theorem, okay, continuously. So let's apply AF square. AF square is equal to 6 square plus 9 square. 6 square plus 9 square, this is 117. And AF square, take square root both sides. So AF is equal to under root 117. So AF is 117. So I will write it 117. Now let's find the last side, which is FH. So FH is, let me now remove again the extra things, extra lines. Now let's find this FH. Let me remove that one line as well here. Yep. Now you see this is another triangle. This one, that one, which is on the back side of that shape, okay? The back side of that shape, there is a triangle. We want to find FH. This is given, that is 6, you see, this is 6, so it means that is 6 and that is also 6. And that is 13, this is 13, so this is 13, this is also 13. So 13 and 6 both are given. So it means FH square is equal to the longest square plus 6 square plus 13 square. So 6 square plus 13 square is 205. Take square root both sides. So FH is equal to under root 205. So this is under root 205. So we calculated all the three sides. Now you can use very easily the cosine rule in order to solve for the angle. Now you see AH has been solved here 250, AF has been solved 117, FH 205. Now this is cosine rule. So this is the formula. If you are facing confusion with this, revise cosine rule lecture, revise that, try to understand cosine rule and sine rule very uh, understand it completely, so that you are able to use it in different places. Okay, apply sine rule, cosine rule, very important, Pythagoras theorem, very important, trigonometric ratios which we are using in different places, right? What we are doing here, this is Pythagoras theorem, Pythagoras theorem, Pythagoras theorem, right? That is trigonometric ratio which we applied there in order to find out this angle, right? Trigonometric ratio on right angle triangle. So the angle is 76.6, that is the angle. So this is sine and cosine rule in three-dimensional shapes. This is your homework. Try this, solve this question. The vectors, we will complete this vector in the next lesson, and that would be the fourth lesson of this chapter. For till this is enough. We'll start vectors in the next lesson. All right, see you then next time. Bye.